All right, let's talk about the network layer. We've pretty much covered everything in the other videos about the transport layer that you need to know. So let's move on to the network layer. And specifically, we are going to talk about the internet protocol. And for the most part right now, we're going to talk about IPv4 because IPv6 is kind of its own thing. It's definitely growing and it's definitely kind of taken over. But for now, IPv4 is probably good enough. So we'll talk about that for a while here. So who's talking? When we're talking about the network layer, we're talking about communication between devices, specifically communication between these devices across the internet most of the time. It also covers communication within a local network to some extent. But we're not talking about the applications, unlike the transport layer where we're really talking about a browser talking to a server application. Here we're talking about a laptop communicating with a server hardware, a server machine somewhere. And that's what we're talking about here at the network layer. And this is kind of a big deal. The network layer, or the internet layer if you're using the TCP IP model, the network layer is how the internet works. It allows you to connect different networks to each other. So before the internet, we could have local networks where devices could talk to each other. But it wasn't until technologies like routing and the technologies at the network layer came around that we were able to connect these different networks to each other and create a large internetwork, or the internet. And it's really, I mean, the stuff that we're talking about here at the network layer is how the internet works. So at the network layer, we've got these addresses called IP addresses. Now, the way the IP address works, it's basically two parts, and it works a lot like how you would number floors in a building. If you come to my office building, we have 3 floors. All the rooms on the first floor are 100. All the rooms on the second floor are 200 something. And on the third floor, you're 300 something. So the first part, the 1 or the 2 or the 3, refers to what floor you're on. And the second part is a room number on that floor. Now with an IP address, we've got the same kind of thing where the address is split into 2 parts. The first part of the address is the network address, and that tells you what network you're connected to. And the second part of the address is the host address, which is unique to one host on that network. So one device on a network has a certain host address. Now you could have the same host address on different networks, but each host on a network has to have a unique address. An important thing to consider with an IP address is that where that split happens between the network address and the host address varies by network. So down here at the bottom, we've got the 192.168.3 network, and all of them start with 192.168.3, and that is the network address. And 1, 2, 3, 4, 5, 200, 230 are the hosts on that network. And with the 10 network next to it, 10.0.0.0 is the network address, and any address that starts with a 10 is on that network. And 10.0.0.0 is the network address, and anything after the 10 is part of that host address, and similar for that top network. So the subnet mask, which you may have heard about if you've ever looked at your network settings, the subnet mask tells where that split is between the network address and the host address. So the subnet mask is a mask, and you lay it on top of the IP address, and everything that's under the subnet mask is part of the network address, and everything after the subnet mask is part of the host ID. And it tells us where one ends and the next begins, because like I said, it varies by network. So you could do this on your own computer. If you have a Windows computer, open up a command prompt and run ipconfig. If you have a Mac or Linux, open up a terminal and run ifconfig. And both of these will tell you your network configuration, and they'll tell you your IP address, and they'll tell you your subnet mask. And you can check that out and see what your network address is. So who needs an IP address? Everybody. Well, obviously anybody who wants to talk on a network, and specifically, more than just each device, every interface on a network needs an IP address. And we'll show a diagram in just a second that kind of explains this a little bit more. So one device can have more than one IP address. For example, a router. A router connects two different networks, and it bridges the networks and it routes traffic between those networks. And the only way a router can do its job is if it's connected to both of those networks. Well, to be connected to both of those networks, it has to have an interface that's on both of those networks. And if it has an interface, then it's got to have an IP address on each of those networks. And the last bullet here, each network that participates in an internetwork needs at least one unique network address. So we have to have multiple network addresses if we want to have multiple networks. So how many host addresses do you see on this network? Take a second, ponder, maybe pause, look, try and figure out how many host addresses given what we know so far. There are 10. So the first 5 are easy, right? You look and you see 5 computers. So 5 computers, each one has an IP address. So we're going to do that. But then we also have 2 routers. And each of those routers has to have a different IP address for each network that it's connected to. So router number 1 on the left has 2 network connections. It's connected to 2 different networks, so it has 2 different IP addresses. Router number 2 on the left has 3 different network connections and needs 3 different IP addresses. So what does an IP address look like? If you ran ipconfig or if you ran ifconfig before, you saw one. An IP address, in IPv4, it is expressed as 2 32-bit numbers. And it's probably not displayed to you as 2 32-bit numbers. The way it's displayed to you is as 4 8-bit numbers, because 8 times 4 is 32. So we split up that 32-bit number into 4 chunks called octets, 8 octets, and we separate those octets with a dot. So 207.173.75.76, for example, is an IP address, .66, and each of those numbers represents 1 octet in that IPv4 configuration. And below that dotted decimal, you can see a hexadecimal, and that is the same representation. It's a different representation of the same number. So CFAD4842 is the hexadecimal representation of 207.173.75.66. And finally, if you really want to, you can just display it out as binary. And the bottom entry there under IP address is 207.173.75.66 in binary. So the important thing to note, very often you're going to see those IP addresses in dotted decimal format, but all 3 of those represent the same thing. And if you look, say in Wireshark, and look at an IP address, if you look at the data that's in your packets, you'll see it represented as hexadecimal numbers, because that's the way Wireshark represents data from the wire. And finally, the subnet mask is the same thing. Again, it's a 32-bit number. Very often you're going to see it displayed as 4 decimal numbers between 0 and 255, because that's what IP addresses can be. That's how big you can get with an octet, is 255. If all the 8 bits are set to 1, then that's 255. Again, you can do hexadecimal or binary. They're all representing the same thing. Another thing you can do is this shorthand representation. And the shorthand representation is the dotted decimal format of the IP address /24. Now /24 represents the subnet mask. And what that represents is the number of ones in the binary version of the subnet mask. So if we look at the binary version of the subnet mask there, 11111111111111111, etc., with 8 zeros at the end, that's 24 ones out of the 32 bits that you have in the subnet mask. So /24 indicates that you have 24 ones and the rest is zeros in that subnet mask. So like I said, the subnet mask is a mask. And if you overlay, if you take the IP address on the top, the subnet mask on the bottom, smash them together, the ones part of the subnet mask tells you what part of the IP address represents the network ID or the network address. And everything where there's zeros in the subnet mask represents that host ID. The rules for the subnet mask, kind of important to consider, but you cannot have mixes of ones and zeros inside the beginning of that subnet mask. The subnet mask starts with all ones and ends with all zeros. And that spot where it changes from ones to zeros is where that network address ends and the host ID begins. So the top address, the top example here, 1111111111111 with the rest zeros, is a valid subnet mask because you have, looks like 12 ones and the rest is zeros. The one below that is not valid because you have that zero in there, so that's not allowed. It's got to be all ones, then all zeros. Another important thing to note, you can actually tell by the number whether it's a valid subnet mask or not. 255.255.255.128.0 is a valid subnet mask because 255 is all ones and 128 is 1 followed by all zeros, and 0 is obviously all zeros. So that's a valid subnet mask. 255.255.129 is not because 129 is 1,000,000,001. So that's mixing together those ones and zeros. So that's not allowed. So the possible last values for a subnet mask, you can see zeros. You can see 128. Remember, I said that's a valid one. 192 is okay because that's 11 with 6 zeros after it. 224, 240, 248, 252, 254, and 255. And you see the binary representations on the right-hand side. So that's CIDR / notation. And when we talk about a little bit more about IP addresses, we'll talk about what CIDR means. But that / notation, remember /24 is the same as 255.255.255.0 because that's 24 ones followed by a 0. /25, another valid subnet mask, is 255.255.255.128 because that's the same 24 ones that you have in that first one, plus one more 1 followed by 7 zeros in that last number. And 1 followed by 7 zeros is 128. The last one here, /23, is 255.255.254.0. And so that's 1 less 0 than the top one. And 255.255, and then 7 ones followed by a 0 is 254. And that's another good subnet mask. And that's all we're going to say about the network address and the IP addresses in this video. But we'll have some other ones that explain in a little bit more depth different parts of that layer, and we'll have another video that talks more about routing and how that works as well.